Welcome to solverfy.
In this question, we have a single slit experiment in which we pass through a photon as well as electrons, and we see that they actually end up with the same diffraction pattern, right? Where they have the first dark fringe, right, at the angle, right, which we don't know, right? We only know that it is at the first dark fringe. It's the same angle. Well, what this means is that they must have the same wavelength, right, in order to have the same diffraction pattern. Now we can actually relate the wavelength for the electron to its momentum, right, because it's equals to h over p, and h over p, where p is related to the kinetic energy of the electron via p squared over 2m. So P is just 2m times kinetic energy, the square root. This h over square root of 2m times kinetic energy. This is the wavelength of the electron and also the wavelength of the photon, right? So energy of the photon given as hc over lambda. Substituting in this lambda, right? Use this expression. It's equals to c times 2m times square root of k. So the only unknown here is really the kinetic energy, right? This c and 2m are constants, right? This speed of light, this is the mass of the electron. So we can actually evaluate the factor over here a little bit, right? This is actually just 4.05 times 10 to the power of minus 7, and the units over here is actually joules to the power of half, right? Because the kinetic energy will give another joules to the power of half because it's square root. So this is just the expression for the energy of the photon in terms of the kinetic energy of the electron. Now to actually determine whether the kinetic energy of the electron or the energy of the photon is greater, we can just take the ratio, right, the ratio of the energy of the photon with the kinetic energy. Putting everything into the square root of the bracket, right, we get 2mc squared over k. Now, given that our kinetic energy is actually not very large, such that the electron speeds are much slower than the speed of light, we're given that v is much smaller than c. This means that our velocity is not relativistic, and it also means that the kinetic energy is much smaller than the rest energy of our electron. Right, if we really want to, we can actually substitute in K as half mv squared, is equals to 2 times C over V. And we know that since the V is much smaller than C, it means that this is actually a much larger value, right, than 1. So this is greater than 1. Therefore, greater than 1 multiplied by 2 will be a number that is greater than 1, definitely. Which means that the energy of the photon is much larger than our kinetic energy of the electron. Since this is larger than 1, so it basically means that it is a large multiple of the kinetic energy of the electron. Right, so therefore the photon has more energy than the electron.